It's just great to be able to go in every day and know that I'm making progress to understanding the mysteries of the universe. Like, we really don't understand how galaxies evolve yet. I take a statistical look at galaxy mergers overall, and a merger is simply the interaction of two galaxies colliding with one another and forming one galaxy in the end. And by looking at it in the radio bands, I can get information on the H1 content of the merger. And in the optical band, I can look at different properties such as star formation rates, colors, stellar masses, and other properties such as that might be influenced due to the merger.
So when you were at the observatory and doing the observations, did you actually go through the...
What I specifically do is take a statistical approach to galaxy mergers. I take a large sample of mergers and then look at the overall properties of the entire sample and see how that compares to isolated galaxies that are not going through a merger. Galaxy mergers are essentially the biggest collision in the universe. These two massive galaxies that contain billions of stars in them each colliding into one another and eventually combining and settling down into one massive galaxy in the end.
So these were models that he was making of the atmosphere?
To begin with, I met Dr. Rosenberg about 2 years ago at the American Astronomical Society conference, which is where she got me really interested in looking at galaxies. She told me about the opportunity I had to work with the database she was building, essentially, which was the combination of the two surveys.
My approach with the students is usually to try to give them as much experience of various sources as I can. So one of the nice things about this radio survey is that it's a large international collaboration. And it's through that collaboration that Derek's had the opportunity to go down to the Arecibo telescope with actually the PI on the project and several other graduate students and learn not only through me about the project and about the telescope, but through the people who are actually running it, work with other graduate students, giving them different experiences by interacting with the stuff that I do, but also with other people.
She does a great job explaining anything I don't understand, whether it's a technical paper or some method I'm using to try and understand the properties of a galaxy. And she's there to essentially teach me. I'm learning the whole time. I would like to continue work in radio astronomy. Now, where I would do that, I'm not sure yet. But there are several institutes around the world that focus mostly on radio astronomy. I figure it'd be a good chance to apply to different places around the world and maybe see other parts of the world. I camped a lot as a kid back in the mountains of West Virginia, and on a perfectly clear night there you could actually see the Milky Way because it was really bright. You could see all the stars. You could even see the gaps between the stars, which are the dust clouds blocking out the light. And from there it was just kind of like, well, I really like science. I got more into physics throughout high school and beyond that point. And basically in undergrad I decided I'm going to go into physics with a minor in astronomy. And now I'm actually doing the astronomy in grad school.